at the characteristics of exponential growth and decay, and then identify its domain and range in behavior, y-intercept, and asymptotes. So when we look at this first graph right here, we see f of x is equal to 2 raised to the x power. So if I wanted to make a table based off of these values, I'm going to go ahead and start with my xy table. And let's go ahead and start with -2, -1, 0, 1, and 2, and see what those y values are. We'll start with the positive. When 2 is raised to the second power, it gives me 4. When 1 is raised to the second power, when 2 is raised to the first power, I have 2. When 2 is raised to the 0 power, I'm given 1. And then if we plug in negative numbers, we can't really have negative exponents. So what we say is we have 2 to the -1 power, which is the same as saying 1 over 2 to the first power. So this becomes 1/2. And then the same thing here, 2 raised to the -2nd power actually becomes 1 over 2 squared, which is 1/4. And that pattern continues on and on and on, and it approaches the asymptote, which is y equals 0. It will never pass 0, no matter how small this number gets. You'll always find that your asymptote here is y equals 0. And it is the x-axis. Okay? That being said, we need to actually plot these points. At -2, for the x, we're at positive 1/4. At -1, we're at 1/2. At 0, we're at 1. At 1, we are at positive 2. And at 2, we are at positive 4. 1, 2, 3, 4. And then if I use 3, so 2 to the third power is 2 times 2 times 2, which is 2 times 2 is 4, and then 4 times 2 is 8. So the other point is right up here. 1, 2, 3, 4, 5, 6, 7, 8. So we have our exponential growth because it is increasing from left to right and approaches our asymptote, which is right here. So let's go for our domain. This graph will go forever to the left and forever to the right. So our domain in set builder or in interval notation is from -infinity to positive infinity. Our range in interval notation starts at the asymptote and then goes up forever. So our asymptote is at 0, so we're going to say 0 up to infinity. And we are going to use a soft bracket here because we cannot include any point on the line of that asymptote. So we have to use a soft bracket here. In behavior, so basically what this means is look at your x values. As your x value approaches infinity, so as your x value increases, what happens to your y value when we're all the way out here? The graph is way up here, so the function of x will approach infinity. As x is decreasing to -infinity, it is approaching the asymptote. So the y value, it's going to be approaching the number 0. Our y-intercept, what happens if x is equal to 0? So 2 raised to the 0 power is 1, so 0, 1. Our second question is the same exact format. F of x is equal to 3 raised to the x. We're going to do the same exact thing. This question right here was growth. I didn't write it, but it's increasing from left to right. It should be the same thing here because 3 is bigger than 1. So we have exactly the same thing that we need here. We start off with our table, x, y. We're going to go with -2, -1, 0, 1, and 2 for our x values and see what those y values are. Start with the big number. 3 squared is 9. 3 to the first power is 3. 3 to the 0 power is 1. And then if we use -1, that's 1/3. And then if we use -2, it's going to give me 1/9. And that looks like this. I have 3 to the negative 2 power is 1 over 3 squared, which is 1 over 9. Same thing with 3 to the negative 1 is 1 over 3. And that's where I got those two numbers right here. This is a growth graph. And we see that if the base is increasing, like here it's 2, here it's 3, even if it increases by a little bit, the graph will increase even faster than the graph that we saw before. So this is a growth. We're going to go ahead and plot these points. At negative 2, we're at 1/9. So really close to that line. At negative 1, we're at 1/3. At 0, we're at 1. At 1, we are at 1, 2, 3. And then at 2, we are at 9, all the way up here. So we are increasing much faster than we did on the previous graph. Do your sketch as best as you can. We see that we're going to approach this line again, which is our asymptote, y equals 0. So no matter what number you plug in, the smallest number you can think of, a negative in the negative direction, you will still get a positive answer, which means that your asymptote has to be the line y equals x, or y equals 0, which is the x-axis. So y equals 0 is the asymptote. Filling out the rest of the information, our domain goes forever left and right. That's going to be negative infinity, positive infinity. Your range goes from 0 up to infinity. As x is increasing to infinity, so is the function. As x is going the opposite direction, negative, in the negative direction right here, it's going to approach the asymptote, which is 0. And then the y-intercept, when you plugged in 0 for x, you got 1. So 0, 1. That takes care of this page right here.